3 by RTD reduce the lead resistance error using the compensation wire. Bismillahirrahmanirrahim. Assalamu alaikum. Today my topic is RTD. So we will discuss about the RTD, 3 by RTD, 2 by RTD and 4 by RTD configuration. So I will completely describe the RTD, type of the RTD, wire configuration of RTD, Pt100, Pt200, Pt500, Pt1000 and nickel and copper RTD. We will discuss the material of the RTD and range of the RTD and why we are using the 2 wire RTD, 3 wire RTD and 4 wire RTD and what is the difference between. So as usually we know that 2 wire RTD have a highest error because of the lead resistance. So in the 2 wire RTD there is the highest lead resistance error. And first of all I will discuss about the range -200 to 850 degree Celsius range. So between we are using this RTD and thermocouple has a highest range or more than RTD. So 2 wire RTD have a 1 to 5 degrees Celsius error. If we use 2 wire RTD, so we must be familiar that it should be give us a from 1 to 5 degrees Celsius error because of the lead wire resistance. And 3 wire RTD, commonly we are using the 3 wire RTD. And RTD have a single element RTD and dual element RTD. As I will show you this RTD, this is a 3 wire RTD and dual element. So mostly we are using the 3 wire RTD and it is a accuracy is better, and also we are using the PLC, DCS and the transmitter. We are using the 3 wire RTD and its cost is a medium. So 3 wire RTD lead resistance compensated. That's why we are using the 3 wire RTD. 3 wire RTD reduce the lead resistance error using the compensation wire. As we know that 2 wire RTD have a from 1 to 5 degree Celsius error and 3 wire RTD 0.1 to 0.5 degree Celsius acceptable error. And the 4 wire RTD less than 0.1 degree Celsius. And it is very costly and highest accuracy because there was no resistance error, lead resistance error. It is a completely compensate the 4 wire lead resistance error and highest accurate. Lead resistance almost completely eliminated, no resistance error. And if we are discussing about the Pt100, Pt200, Pt500, Pt1000. So Pt means platinum. Pt100 means in the 0 degree Celsius it will produce 100 ohms. And 200 Pt200 means at the 0 degree Celsius it will produce a 200 resistance ohms. And the 500 same is 0.5 kilo ohm or 500 ohms it will be produced. And 1000 Pt1000 it should produce 1000 ohm. Means if we are getting the 1020 ohms, so we will minus the 1000 ohm and we will divide the 20 ohms. And this is a calculation different about all Pt100, Pt200, Pt500 and Pt1000. These all we will calculate the different ranges, different sensitivity. So Pt100 there is a 0.385 sensitivity. So if we are getting the 120 ohms, so we will minus the 100 because we are using the Pt100, and 20 we will divide the 20 into with the 0.385 ohms and we will get the degree Celsius. And same with the Pt200, we will divide the 0.077 ohm, means we are getting the 220, so we will minus the 200 and 20 we will divide the 0.77 ohm, means 0.77, we will get the degree Celsius. As said, Pt500 we will divide 1.92 ohms. Sn, the Pt1000, we will divide the complete resistance, we will minus the thousandth resistance, after then we will divide the 3.85 ohm and we will get the temperature in the Celsius. These all temperature depending on the model of the RTD. So as Ni, we are using the Ni 100, Ni 120. So Ni means nickel, and when we are using the Ni model, we are using in the lead, and its range is a minus 60 to 180. And we are using also the copper RTD. So copper RTD minus 50 to 150 degrees Celsius, and its model also Cu50 and Cu100. So all resistance temperature detector have a different model, and we are discussing about the materials of platinum, copper and nickel. These are three materials using for the RTD. My name is Faisal Ahmed and you are watching Instrumentation channel. Allah Hafiz.